Okay, we should be live now. Yes, hello. So we've got some action in the chat room, so that in the live chat, which is good. Um, right, welcome to the first Furnace Academy science lesson aimed at all of the students at Furnace Academy. Those in year 10 and 11 will know that I've been doing some of these for hello folks, good to see you in the live chat. Yeah, year 10 and 11 know that I've been doing some of these for Key Stage 4 to try and keep moving, especially our year 10s, forward with the stuff that they need to know for their GCSE, because obviously it's quite a crucial time for them. Now, what we're going to do is on a Tuesday, I'm going to start doing some lessons that look at the fundamental science that everyone needs to know to be able to understand everything they need for the GCSE. So certain topics, it doesn't matter which year you're in, you really need to get your head around, okay? And we're going to start with some fundamentals of chemistry, and then we'll see where we go from there. So today's lesson is going to look at chemical reactions and try and get to the bottom of what is actually happening in a chemical reaction, and what you really need to be able to do and understand before you can get your head around lots of different stuff. Just one quick word. I've got two moderators on in the live chat, and I'm going to switch the live chat on and off. So there'll be time to do the live chat, which is when I'll need some interaction from you, and there'll be time for you to just crack on and do the stuff and do the tasks. So what I'll do now, it's good that lots of people are in, but if I go, you should be able to see now that I'm looking at the live chat. And if I go here on the settings, if I disable live chat for now, then we can crack on with the lesson. Okay, so let's make a start. Right, because we're starting, I'll just check my OBS. Yep, no, you're looking at the PowerPoint. Good. I tell you, this is so different from trying to teach a lesson in front of you because you get no feedback. I feel like I'm just talking to nothing. And so yeah, it's just bear with me. It's because it's quite a new skill this for me. So we'll see how we do. Okay, so chemical reactions. Let's make a start. Anyone who I've taught before knows that every lesson I start with a quick quiz. So what I need you to do now is I just want you to get a scrap of paper, or it can be written down on the side of your worksheet or anywhere, and I just want you to jot down the answers to a quick quiz. Now, normally in class, this is to sort of recap stuff that we've done before to try and get it to stick in your memories, you see, and sort of get transferred to your long-term memory. But this is just going to be a quick science quiz for everyone to see, to get us going, get us awake, remind us of a few key concepts. So once we're done, 8 questions coming up, quick fire. Once we're done, you can post your scores in the live chat and we'll see how we're getting on. All right? Okay, so question 1 of the quick quiz. Beginning with P, what is the chemical reaction that plants do to produce their own food? So I'm looking for a word beginning with P that is a chemical reaction that plants do to produce their own food. Okay? Right. Question 2. Okay. Complete the name of the famous scientist, Sir Isaac what? Okay, so there's a famous scientist called Sir Isaac something, famous for understanding the orbital motion of planets, and very famous for his work on forces, his laws of motion. He's a bit of a superstar, really. What's he called? Question 3. Beginning with A, what is the name of the super tiny particles that all stuff, now when I say stuff, like, everything, birthday cards, wallpaper, whatever, cushions, everything, wood, plastic, all sorts of stuff, we call that matter. Okay, so all matter is made from super tiny particles and the name of those particles beginning with A. So what's the name of those particles beginning with A? Super tiny, can't see them. There's about 1 million of them in a grain of sand. 4 million of them in a grain of sand. Okay, question 4. Name one thing. By thing, I mean an organelle. Okay, so a structure in the plants in a cell that plant cells have, but animal cells don't. So, animal cells, plant cells, they've got stuff in them. Now, plant cells have got extra stuff that animal cells don't. Can you name this? You've got 3 to go at here. I just want one. So, one thing that a plant cell's got, but an animal cell hasn't, please. Okay. Right, question 5. Beginning with R this time. What chemical reaction do living things, so that is organisms, do to release energy from their food? So what chemical reaction do living things do to release energy from their food? Beginning with R. Question 6. Name one acid that you've used in science practicals at school. Right, so I know it's a while since we've been in school, but even my year 7s, we've done quite a few practicals. I know all of the science teachers have done practicals using at least one acid. Can you remember the name of an acid that you've used in a science practical? Okay, question 6. Question 7. If you divide, it's a bit of maths here, if you divide distance by time, what do you get? So what's the product of when you divide distance by time? What quantity are you working out if you do distance divided by time? Physics question there, my favourite. Now, question 8, and final question. Beginning with P, what table lists all the different elements we know of in the universe? Okay, so there's lots of different elements that we know of, and we put them in a table, an ordered table, a structured table, beginning with P. Dmitry Mendeleev was fundamental in sorting this table out in its current guise, but what's it called beginning with P? Right, 8 questions. You should have jotted them all down. There's the first 4. There's the second 4. I'll do answers in 30 seconds. I'm going to use this to try and keep on time, because otherwise I'll waffle on and you'd never get anywhere. We've got quite a lot to do today, okay? So just get those down. We'll go for the answers, all right? And then we'll have a look. You can post your scores in the live chat and we'll see how we're getting on. Right, so answers. That, of course, is photosynthesis. Give yourself a tick. So you should be marking these as you go along, all right? So you're going to get a score out of 8. These all say 1. Ignore the numbers being wrong. Okay, famous scientist. That's going to be Sir Isaac Newton. Okay, famous for Newton's laws of motion, etc., etc. Now, atoms. Atoms are the super tiny particles that all matter is made from. Hope you got that one. And you had 3 to go at. So plant cells have got a cell wall, chloroplasts, and a vacuole. Animal cells don't have those things. So that was your 3 to go at. Okay, cell wall, chloroplast, or vacuole. The 3 things a plant cell has that an animal cell doesn't. Hopefully you got that right. Miss Coulter will be happy if you got that one right, and Miss McIntosh, the biologists amongst us. Good. Right. Next set. Oh, the numbers are right now. Well done, Mr. Barnes. Respiration, right, is the chemical reaction that all living things do. Trees, plants, not just humans, is anything that's living, bacteria, they respire. And they do that to release energy from their food. Okay. Respiration's really misunderstood. I think I might do one of these fundamental lessons on respiration further down the line. So respiration is the reaction that goes on in every cell in our body to release energy from, well, glucose in our case. Okay, one acid, you could have had hydrochloric, sulfuric, or nitric. If you divide distance by time, what do you get? Well, distance divided by time gives you speed. Bit of maths, all right? So miles, distance per hour divided by hours, time, gives you miles an hour, a speed, okay? And this is the periodic table, all right, that lists all the different elements. Ace. Okay, I'm going to enable a live chat and you let me know what you got out of 8 quickly, all right? So 10 minutes to do the quick quiz. Hey, it was a quick quiz, so we're getting there. Right, that should be me back again. And that should be the browser. If I can come on, you can do this. You're looking at the browser, aren't you now? Good. I'm hoping you see me do this now. If I enable live chat. Right, give me your scores then. Fire your scores on, please. Let's have a look. Brilliant. Lee, 8. Excellent. Good. Hannah, brilliant. Jacob, excellent. Awesome. Neve. Matthew, Amelia, hey, we've got loads of new people in there. Lewis, excellent. Awesome. Hey, so we're getting there. Moxicillin, I like that name. So, Alex, right. Sorted. Hello, Tegan. Good to see you. Hey, this is superb. We've got a load of people watching this, and it's obviously working. Superstars. Right. Hey, amazing. Yeah. Brilliant. Right. Don't spam your messages because the moderator will time you out. Just one, that's fine. Right. Guys, I'm going to have to get cracked on, but that is superb. All right. Very, very well done. Okay. Yeah. Awesome. Right. I'm going to... let me have a look at this. So I'll disable the live chat. Cool. And we'll go here, so you should be looking at me. Yeah, I have to talk the process through in my head, otherwise I just get lost entirely because I'm not looking at what you're looking at. So it's like, but we're getting there. Right, let's crack on with this lesson. So, here are our learning objectives. You should be looking at the PowerPoint now. Are you looking at the PowerPoint? I hope you're looking at the PowerPoint. Right, these are our objectives for today's lesson, and I'm going to this lesson. I'll get it inside an hour. All right, and we're going to hit these objectives, and we need to focus on hitting these objectives. I want you by the end of this lesson to understand what the basic principles of a chemical reaction are. So, what actually goes on when we do a chemical reaction? All right, because we need to know the underlying sort of process, really. And it's very simple, very straightforward. Okay, we just need to put it in the right words. It's a thing about just knowing the right terms or the right words to explain what's happening. So that's our first job: understanding how we describe a chemical reaction, what's happening. Second objective, a bit more tricky but well achievable. And there are people in year 11 who still don't understand this. And this number 2 is like the key to being a good chemist, in my opinion. I wish my teachers had focused more on this stuff when I was at school, because I struggled with chemistry compared to physics because I didn't get my head around this. So I'm hoping if we can get our head around what actually the word and the symbol equations represent, because they're a bit scary to start with, but they don't have to be, then you just sort of get a better idea. Chemistry stops being a foreign language then and starts being a bit more easy to understand. So we really need to try and get these two done. So, like all good science lessons, we're going to start with practical, okay, to understand the basic principles of a chemical reaction. So, do not worry if you haven't got this equipment and you're just joining this to watch the lesson. That's fine. I'm going to demo it and you can use my results. So it's fine if you haven't got this, don't worry at all. If you have got it, because you saw it on the email and stuff, that's brilliant, and you can do this with me in a minute once I've shown you what I want you to do, okay? I had to be quite conservative because obviously this is for everyone, so I was having to think of something that we could do that, one, was safe, all right, don't want you blowing your blooming house up. 2, it had stuff that you might have been having in the cupboard or that you might have had anyway. All right, so it was stuff that most of you might have. And and then it had to be useful. The practical we were doing had to be useful. It had to help us try and learn the stuff we're trying to learn. Now, you probably don't know this, but doing practicals in the classroom in the science lab, okay, we get lots of training on how to do those safely. You know, when we're dealing with the acids and we're dealing with the alkalis and the toxic chemicals and stuff, we get loads of training and we get loads of we have loads of practice when we try to become a science teacher on how to make the practical run well and run safely, etc. Okay, now you're on your own here, right? I'll tell you what I want you to do, and you hopefully you can do that, and then we're good. All right, but so there is zero risk involved with this if we follow the instructions. If we start squeezing vinegar in our eye, etc., etc., we'll just get an itchy eye. But let's see if we can do this. All right. Now, some of you might be like, "This is a bit tame," but this is the best we've got when we're in this lockdown. All right. So this is what I want you to do. You should have these ingredients, and I'm going to use vinegar. All right, just because I had some standard Tesco's chip vinegar. Okay, and the other thing I've got, which Jeffrey Giraffe is kindly, my assistant, is kindly holding, is some baking powder. So I've got baking powder and vinegar. Hopefully you can see them. You might have vinegar, you might have Coke, you might have fruit juice, all right? You might have a bit of fruit juice. I haven't got any Coke because I didn't have any of the kids who drank it all. They're eating me out of house and home. I'm spending about 3 times what I used to spend on food, but there we go, never mind. And you might have had your baking powder, might be called something else, or you might have got something like an indigestion tablet that you crushed up. Okay, that you need to crush up. All right, so this is what you're going to do. First thing you're going to do, right, is you're going to write down on your sheet, and if you haven't got that worksheet printed out or in front of you, don't worry. Everyone's got different like devices and stuff, so just do your best. There's no stress whatsoever. Just write this stuff down on a piece of paper. Just jot it down, make some notes. So I'm using vinegar, so I'm going to write vinegar. Vinegar is my reactant. We'll come reactant number 1. We'll come on to talk about reactants in a minute. And then my number 2 is going to be my baking powder. Okay. So I'm going to write those on my sheet. All right. And then you'll notice on your sheet that you've got a space to write down the time it takes for the reaction to stop. Okay. So if I try and show you this. Excuse me. Right. So you've written down what you're going to use out of cola, vinegar and fruit juice. You've written down what your reactant number 2 is. And here is where you're going to say how long it takes for the reaction to stop. All right? So, what you do, you get your glass. You need 100 ml of your vinegar in my case, or whatever your reactant one is. Now, some of yous might have got a measuring jug, right? I bet you there's probably about one person out there with a measuring jug, which would give you exactly 100 ml. I'm going to pretend I've not got that, right? I'm going to do it the old-fashioned way. And this is why maths is just everywhere, right? That is 568 ml, right? I'm going to call that 600 because I want to make it easy for myself. So if I split that into 6 equal parts, I'm going to have 100 ml, aren't I? So if I half it, but a bit lower because that's a bit narrow at the top, you've got to think about these things. And then split me half into 3 sections. That'll give me how much is about 100 ml. So 100 ml for me is about that much. So you can estimate this quantity if you don't have a measuring jug, all right? But it's quite a good skill being able to estimate quantities like that. Okay, so into your thing needs to go 100 ml of your reactant. So do it now, please. Don't get it on your computer. If I get this on my partner's iMac, my goose is cooked. Right. So I've got 100 ml of my vinegar. Okay. Put the lid back on. You don't want a vinegar spillage. Now, number 2. Reactant number 2. Okay. Get your teaspoon. 1/4 of a teaspoon. If you put more in, it's going to last for ages, this reaction. So you want about, that's a bit much, 1/4 of a teaspoon, right? And this is what you're going to do. You're going to get your timing device. I'm hoping, check. Oh, come on. I ain't got enough. I wish this giraffe had hands. Right, yeah, look. Get your timing device. Okay. Put reactant 1 into reactant number 2. Give it 1 stir. Start your watch. Start your timer. Okay. You'll notice the reaction because you'll see bubbles, you'll see fizz, you'll hear it. Okay. And then what I want you to do is I want you to put your ear to it. And you'll hear the bubbles, the gas being produced. That's carbon dioxide. We'll come to that in a minute. But what you do is you need to listen for when this reaction stops. Now, if your hearing's not so good, that's fine. You can look at it, but the bubbles stay at the top. So the best way to see it visually is to look at the liquid and see if the bubbles are still being produced in there, because they'll stay on the top after the reaction stopped. So mine's still going. You have to listen carefully. Okay. Right. When your reaction stops or gets right down to a low level, because what happens is the bubbles on the top start popping and you can hear that a little bit. So when the reaction calms right down, should take about 3-4 minutes. Mine's getting a bit calmer already. So when it drops away and the reactions stop your stopwatch, write your time on your sheet. So write your time in there where it says time for the reaction to stop. If you've not been able to do the practical, I'll put my time in. Okay? I'll put my time on there. Right. Keep listening. I'm going to go to the live chat and you can start posting the times it took your reaction to stop. Right, mine stopped. Okay. So, in here. So mine took 121 seconds to stop my reaction. Yours should be about starting to finish off now. I'll get on the live chat. Let's hear how long yours have taken, and you can write it down there. If you've not done it, use 121 seconds. Remember, this is seconds, folks, not minutes. If you've got 3 minutes, 60 seconds a minute, 3 times 60, 180 seconds. All right? Let's convert the seconds, please. Come on, computer. He's struggling a bit now. Right, so times, please, for your reactions onto the chat. Hopefully. So once you've got your times, stick it down onto the chat. I want to see, come on, I hope this is not, I'm not the only one who has seen this. Right, superb, brilliant. Yes. Hey, this is science experiments remotely. Hey, Pepsi Max, Nave. That's why you need to clean your teeth after you've had some Pepsi Max, because the right, Kira measured your reactants properly, exactly, because there is. Right, superb. Right, hang on. Well, you can see live chat, can't you? So it doesn't matter that you can hopefully now see me looking at live chat. Right, amazing. Some people have used mine. Some people have used Alfie. It's great to see you, mate. Lewis, Jacob, Max, loads of folks in. This is awesome. Right, brilliant. I'm really happy because we've done a science practical remotely in lockdown, and it's worked. You lot are amazing. All right. Yeah. If you couldn't do it, Joe, don't worry. Use my time. Okay. Right. So. Right. We have an issue with the chat. Yeah. So that's classic trolling, but hey, literally, there's only one loser here. Now, let's go. Let's crack on. Right. So if I disable the chat. Good. And you should now be looking back at the PowerPoint. So, what we need to do now, right? We've done the practical. We've got some results. So we've seen a chemical reaction take place, all right? And we've timed it. We've seen how long the chemical reaction took place for. We need to represent that chemical reaction between our fruit juice or whatever it was and our baking powder in terms of a word equation and a symbol equation. So we're going to spend the next half hour, understanding. Okay, we've seen some chemistry. Now we need to understand what was it that was happening and how a word equation and a symbol equation represents the reaction that you just saw taking place. All right. So let's crack on. This stuff is on your sheet, but I'll put it onto the PowerPoint as well. Right. If you use fruit juice, right? So if you use fruit juice, we're going to look at the equation that would have happened if you use fruit juice. Do not worry. Everyone needs to switch onto this. It's irrelevant whether you use fruit juice or not. I just wanted to give you options so you could have something to do it with. But we're going to look at the reaction if it was fruit juice, okay? So we're all going to do that now. Because basically the vinegar or the fruit juice just had different acids in, okay, which was part of the reaction. So it doesn't matter. We'll look at all three in time, but we're going to go in detail through the fruit juice one, okay? If you did fruit juice, right, the word equation will look something like this. And this is where we start to see chemistry as a foreign language unless we think about what this actually shows and work it out, okay? So the aim for me now is to take the mystery out of what the word equation is and out of what the symbol equation is. All right, so in your orange juice, there are lots of different things, substances, there's a lot of water in there, but the active ingredients or the reactant that is taking part in the chemical reaction is something called citric acid, okay? So that's why citric acid is there in that word equation. In our baking powder or our indigestion tablet or our baking soda, the active ingredient is most likely sodium bicarbonate. So that's why that's there, okay? Now, it gets even more scary when we look at a symbol equation, okay? I mean, what on earth is that? Or small numbers, large numbers. symbols, not real words. I mean, it can appear very, very scary, but it is quite straightforward if you engage your brains and follow this through. So, okay, we'll start with the word equation, right? We have got for fruit juice, but this is the first one on our sheet. If we look at our document, okay, they're there for you, all right? So this is our first equation. We're going to do it together, and you're going to do the ones after that to see what's actually going on, okay? So if you're writing, you need to be making the notes here in this table at the minute, because here are the word equations and symbol equations for you, okay? So, word equation. In any chemical reaction, okay, so the chemical reaction is what you see when you see the bubbles happening, okay? There's something going on. What is it? Well, you start with two or more reactants. So these are our reactants. Can you label citric acid and sodium bicarbonate as reactants on your sheet, please, now? Okay. So this is the citric acid, which you find in your fruit juice, and your sodium bicarbonate that you find in your baking powder or your indigestion tablet or your, I forgot what the other one was. I said you could get baking soda, okay? Because it's those two things that react in your orange juice and your baking powder. Now, a chemical reaction happens, and you end up with three different products being formed, okay? So your citric acid and your sodium bicarbonate, the reactants, the chemistry happens, which we'll look at in a minute, and you end up with three different products: sodium citrate, water, and carbon dioxide. So if you were looking, okay, if you were looking at your reaction, if you'd done it with fruit juice, what you're looking at now isn't citric acid and sodium bicarbonate in there. It's changed. It's sodium citrate, water, and carbon dioxide. Well, the carbon dioxide are the bubbles that have escaped. But fundamentally, in chemistry, in a reaction, you have reactants that you now should have labelled on your sheet. That change through a chemical reaction into products, which you should have also labelled on your sheet. Okay, so that's what the word equation does. It tells you which substances are taking part in the reaction, which two you start off, or three, or whatever you start with, and then which different substances you end up with after the reaction, which are your products. Okay? Good. So, next thing, let's look at the symbol equation. Okay? So, I brought in the symbol equation here. Now, don't worry if this looks difficult. It's not as difficult as it looks. Okay? But to understand chemistry at GCSE, you have to understand what's happening here. Okay, you've got to get a picture in your head of what's happening. So we're going to take it step at a time. We're going to start with the citric acid. Okay, so if we look at the citric acid, right, so here are reactants, here are products again, so label them on your sheet. The C6H8O7 and the 3NaHCO3, they're your reactants here. And you've got your product as well. So again, label those on your sheet as reactants and products, because fundamentally in a chemical reaction, you have the reactants, there's the chemical reaction, and you get the products. Okay. So let's get to the bottom of what symbol equations are, because if you can get your head around this, you're way ahead of the game. Right, citric acid. Okay. It's the ingredient in the orange juice that is involved in this reaction. It's the reactant from the orange juice. So C6H8O7, these symbols. This is telling you what a molecule of citric acid is made up of. Okay, and by molecule I mean the smallest sort of repeating unit of citric acid. These things are tiny, okay? It's a few atoms, this molecule, isn't it? We can't see it, and there's millions of these molecules in the orange juice. But when we do chemistry, the symbol equation just shows you the simplest unit of that thing, the simplest sort of building block of citric acid. Okay? So, what on earth is that? What's that representing? So, this is a picture that represents a molecule of citric acid. Now, some of you'll be on phones, so this will be difficult to do. Some of you'll be on bigger screens. But I'm hoping you can see, count the carbon atoms now represented by the C's, right? Count them, you should be able to find that there is 6. All right? Count the hydrogen atoms represented by the H. You should be able to see that there's 8. You should be able to count 8. Okay? Count the oxygen atoms. Surprise, surprise, we've got 7. Okay? So what this C6H8O7 business means is it just means that citric acid is made up of a molecule containing 6 carbon atoms, 8 hydrogen atoms, HA, and 7 oxygen atoms. All right? That's it. So it looks mad, these numbers and letters, but it's just telling you what atoms you've got bonded together. So these lines connecting the atoms, they're the chemical bonds. You learn about them loads, okay? What atoms are chemically bonded together in a molecule of citric acid? And we've got 6 carbons, 8 hydrogens, 7 oxygens. All right. I want you to we go, cancel that, I don't want to print. I want you to write this down now. Okay, so we've got 6 carbons. We've got 8 oxygens. No, we're not. Of course we haven't. We've got 8 hydrogens. And we've got 7 oxygens. Okay, write them down. Okay, that's. There you go. 6 carbon atoms, 8 hydrogen atoms, 7 oxygen atoms, all joined together, making citric acid. Write them in your sheet now. Okay. So, we should be looking at the PowerPoint now. Let's have a look at the next reactant. So this is sodium bicarbonate. So that's the thing in here that is a reactant that reacts with the citric acid. And let's have a look at that. So here we have 3 molecules of sodium bicarbonate, the big number. All right, it just tells you that you've got 3. We had 1 molecule of citric acid, didn't we? We've got 3 molecules of sodium bicarbonate that are taking part in this reaction. All right, so there's 1. That's what 1 looks like. 1 sodium, that's Na. 1 oxygen, 3 oxygen ZOs, 1 carbon, 1 hydrogen. Okay, so that's what 1 molecule looks like, and we've got 3 times that, haven't we? Okay, we've got, in effect, 3 sodium bicarbonate molecules, and that's all the symbols mean. They just tell you what atoms are bonded together in a molecule of sodium bicarbonate. All right, so we've got 3 lots of Na, haven't we? So we've got 3 sodium atoms in total. Look at the brackets, the bottom picture, the brackets. That's what you've got essentially by having that big 3 at the front. It's 3 lots of that molecule. So 3 lots of 1 Na, 1 sodium is 3 sodium atoms. We've got 3 hydrogen atoms because we've got 3 lots of the H. We've got 3 carbon atoms because we've got 3 lots of the C. And we've got 9 oxygen atoms because each molecule has got 3. And you've got 3 molecules because of the big 3 at the front, so you've got 9. Okay, so back to our sheet. Let's have a go. You fill this in if you can. So we've got 3 sodium. Okay, 3 sodium atoms, 3 hydrogen, 3 carbon, and 9 oxygen. Not 3 because I'm pointing at the screen here. Hopefully you can see the document. Because that 3 means each molecule, this is a molecule, and that 3 means you've got 3 oxygens in each molecule, but you've got 3 molecules. So 3 times 3 is 9. Okay? That's how we work it out. So, while we're looking at this worksheet, we have a word equation. Gives you the name of the reactants and the names of the products, what you get after the chemical reaction. Symbol equation just tells you what atoms are bonded together in the reactants and in the products. And that's it. All right? Big numbers in the front just mean you've got that many molecules of each of the substances happening in the reaction, okay, and being involved in the reaction. So, back to our PowerPoint. Not control. I don't want to print. I need to change my shortcut keys because it's set in Word to print. Right. So here we are. Right. I know this is difficult, but if you watch this video back, if you need to, and work it through, you will be able to get your head around this. Okay. And I can also give you more support. I know it's difficult doing this remotely, but this is the best we've got. And really try and get your head around this because it's super important. Okay. Right. We've got our citric acid. There's the picture. We've got our 3 molecules of sodium bicarbonate. There's our 3 molecules. Now, those are our reactants. These are our products. Okay. Sodium citrate, water, carbon dioxide. We've got 1 molecule of sodium citrate, 3 molecules of water, and 3 molecules of carbon dioxide. They look like this. Okay. What I want you to do, okay, is I want you to fill the sheet in. So here, I want you to write down in each, just underneath the symbol equation, what atoms are in each of those molecules, or how many atoms are in the combined 3 water molecules or 3 carbon dioxide molecules. So can you try and fill that in now, please? I know it's tricky, but give it a go. Okay, we'll go back there, so that might help you. Okay, so you just need to write underneath the symbols how many of each type of atom are in those molecules, or those multiple molecules, those 3 water molecules. For example, how many oxygens have we got in the 3 H2Os? Well, we've got 3 because there's 3 molecules each, 1 in each. All right. Okay. Right. Have a go at that now. I'm going to go to the live chat. Apologies if there's any offence caused by, I think someone was trying to hack in. The moderator's dealt with that very quickly, so well done. I have got a filter on it for any obscenities, but obviously people spend their time trying to make up something obscene through normal words, which seems like a waste of time. You should concentrate on learning your science if you want to get anywhere in your life. Okay, so I'll go back to the live chat. and see how you're getting on. Because what I'd like you to do now is try and fill the rest of the sheet in terms of label the reactants, label the products, and write down from the symbol equations how many of each type of atom are in there. Okay, P stands for phosphorus. Okay, right, I'll go here because this is the main part of work I would like you to do. So have a go at filling in. Label these up as reactants or products. Label these up as reactants or products, and fill in how many of each of the atoms are contained in those molecules. Okay, do it for vinegar and for cola. See how you get on. This P stands for phosphorus. Okay, so in this case, we just have one. Okay, right, crack on. See how you get on. I'll get to the chat to deal with any questions. If any more abuse is part of there, I'll just shut the chat down if that needs to be done. Hopefully not. We'll see. So, let me know how you're getting on. Any questions I can sort with, I can try and sort on here. Okay? If you're struggling, don't worry. You might have to watch this back a few different times. You might have, like, Amelia, don't worry if you don't have the sheet. The thing to do if you don't have the sheet, okay? Yes is the answer, Kira. Brilliant. Yes, right. So it's difficult to slow down without taking loads of time. You may have to review the video, okay? Or you may have to email me your questions separately if I can't fix it on here, okay? But, yeah. Right, good. Okay. If you don't have the sheet, I'll put the sheet up on the screen and you just have a go at writing down which atoms you think are represented by the word equation. So keep going. I'll keep one eye on the chat. Right. Okay. So if you don't have the sheet, I'll leave that there. And so what I want you to do, here is a molecule, if you're using vinegar, of acetic acid. This is a reactant, because these are the reactants and these are the products. Okay. So this symbol equation is telling us what atoms are bonded together in a molecule of acetic acid. So what I'm after is you to think, okay, H, this is hydrogen, and we've got 1, and we've got 3 more, so we've got 4 hydrogens. Okay, and so on. We've got 2 carbons. We've done the hydrogen, haven't we? And we've got 2 oxygens. So those are the atoms bonded together in, and that's all the symbol equation is telling us, folks. This tells you that one molecule of acetic acid has got these atoms bonded together in it. and we can work through the process for each of the reactants and each of the products. Okay, I'll give you, because we've got 9 minutes left. We've got 9 minutes left of this. Okay, I'll give you another couple of minutes. You can always finish it off afterwards. Okay, you might want to review the video and then try and look back at it and go over some of my explanations again. Because I want to round off within the hour. So I want to round off the lesson by 3 o'clock, and I just want to review what we've been looking at. And there's one more very important principle about the reactants and the products and what the actual chemical reaction is, and I want us to get that done before our time is up. Okay, right, check the chat while you're finishing that off. Right, so Kira, HC2 is a hydrocarbon. I am simplifying things slightly because it's the principle that brilliant Jenny, brilliant Hannah, excellent Alfie. Yeah, Thomas, don't worry, send me an email with the things that you've struggled with, or have a look at it again once it's uploaded to the science department channel. All right, brilliant. So I've simplified things slightly, Kira, to get the principle across of what the word equation shows and what the symbol equation shows. Because if you get the principle, then you can look at how things are bonded together, and because I'm just trying to make sure that we understood what's going on. Okay, right. Last little bit of this lesson. You've been awesome, you lot. So let's go here. You're doing really well. If you've stuck at this, don't worry if you've got stuff to do. I'm going to knock the live chat off, and we can just summarise what we've been doing. Okay, and then that's it. We got 3 o'clock, which is good. Right, so this is the thing I want you to think about, right? These were our reactants, right? Citric acid and sodium bicarbonate. So remember, this was citric acid in the orange juice, and that is a molecule, or made up of loads of millions of these molecules of 6 carbon atoms, 8 hydrogen atoms, 7 oxygen atoms. Okay? And then in our baking powder, whatever we used, is our sodium bicarbonate. And in the reaction, there's millions of these molecules, but in the reaction, 3 molecules, 1 sodium atom, 1 hydrogen atom, 1 carbon atom, and 3 oxygen atoms that are bound together, are involved in this reaction. So this is the basic unit of the reaction that's taking place millions and millions of times. Okay? If we look at what we end up with, okay, what I want you to notice is that the atoms that you end up with in your products, right, they're exactly the same as the atoms that you start with in your reactants. There's exactly the same atoms, exactly the same number of each type of atom, okay? All that's happened, and this is what chemical reactions are. Chemical reactions are where the bonds, these lines that are drawn between the atoms, these chemical bonds, when the citric acid and sodium bicarbonate meet, these bonds are broken down. This is the actual reaction. The bonds break down, so those lines are broken, that are representing chemical bonds are broken, and then new ones form between exactly the same atoms, but they're in a different order. We've got CO2. We've got one carbon and two oxygens joined together now. We've got carbon dioxide. They're the bubbles. So chemistry is basically the atoms that are bonded together in the reactants, the bonds breaking down, and exactly the same atoms, just rearranged, bonded back together in different orders and in different molecules to give you your products. But they're the same. Look, if we count on here the number of sodiums, I've got 1, 2, 3 sodiums, haven't I? Right? If I looked at what I started with, over on my sodium bicarbonate, I've got 3 sodiums. They're in 3 separate molecules, but that doesn't matter. The atoms, the bonds break, new bonds form, and that's what chemistry is. That's what a chemical reaction is. All right? It's the bonds breaking in the reactants, the atoms rearranging, forming new products by forming new bonds and new molecules. So we go from citric acid and sodium bicarbonate, word equation, to sodium citrate, water and carbon dioxide. We've got 3 new products, but they contain the same atoms, just chemically bonded differently. And it's that's a chemical reaction, that process of breaking and making bonds. All right? And the symbol equation isn't tricky. It's just telling you what atoms are bonded together in each of the molecules. Okay. Right. My watch says 14:57. So this is a 3-minute summary. You lot have been brilliant. Again, I'm just sat in my room talking to a computer, but I hope you've enjoyed it. Like I said, it will go onto the science feed to review if you need to. You can email me questions. Next Tuesday, it will be Fundamentals of Chemistry Lesson 2. We'll probably look at the periodic table because it'll all build and link together, and we'll keep coming back to this. But for now, here is a summary of today's lesson. Chemical reactions start with reactants and end up with products. And there we have an example, okay, as if we were using fruit juice. We have our reactants, we have a chemical reaction, we get our products. The word equation tells you the names of those reactants. So in our orange juice and our thing, our baking powder wheat with citric acid and sodium bicarbonate were the substances that were actually reacting. And we were getting, after the reaction, sodium citrate, water, carbon dioxide, still a few bubbles. Okay. The symbol equation, okay, tells you what particles are chemically bonded together in the molecules that make up the reaction. So here's our sodium bicarbonate, and we know it's 3 lots of this molecule, and that's what the symbols show you. Okay? And finally, with 2 minutes to go, the number of each of the different particles is always the same before and after. So the atoms that are bonded together in the reactants, the bonds break, the atoms rearrange, the bonds are reformed, so you get new products. That's chemistry, that's chemical reactions. And the atoms don't change. If you start with 5 hydrogens in your reactants, you're going to have 5 hydrogens somewhere in your products. Okay? They're exactly the same. They just form different molecules and new substances. Okay. Well done, folks. That's it for today. 1 minute to spare. I hope you've enjoyed it. It's the best I can do from where I am. Thank you for watching it and taking part in the practical and everything like that, and trying to get your head around what chemical reactions are. I'll say bye for now. I'll leave the chat running, the live chat. I'll switch the live chat back on to say bye for a couple of minutes, but I'll shut this live stream down and we'll ignore that bit. Bye for now. Okay.